In this video, we are going to be discussing how to evaluate a piecewise function. So a piecewise or a step function using a graph. A piecewise function is a function that has different pieces to it. In our case, they're going to be linear pieces or absolute value pieces of a function, but it's broken up into different domains across the coordinate plane. So today we're just looking at how to find the y value that corresponds with different x values. For example, here is our piecewise function. We can see it has two horizontal lines and then one linear equation in the middle as well with a y-intercept of 1. When we are evaluating these, we want to just look for the x value that's in the parentheses. Recall that when you're looking at f of x, these are x values. We want to know when x is -4, what is the y value? So we find an x value of -4 and we see what the y value is on the graph, which here it's -6. This means f of 0, so when x is 0 on the graph, what's the y value? When we get to c, we run into an issue because when x is 0, I see a point here at 5 and a point here at 4. Recall when we would graph linear inequalities that an open circle means the value is not included there. So on a graph, we want to look for the closed circle to determine what the function value is there. So here, even though there's 2 points that I'm seeing, I want to look at the closed circle at 1, which is a y value of 4. And again, at -2, I see 2 values, an open circle and a closed circle. I want to go with the closed circle. Can do another example. When we're looking at the graph of h of x, these are all the x values. So we want to find the x values on the graph and see what their corresponding y values are. So the first one, when x is -5, I trace it up to the graph. The y value here is 3. When x is -2, I see a point up here at 4 and a point down here at -6. I want to go with the closed circle, which is at -6. When x is 0, I get a y value of 3. When x is 1, I see if I look up, there's an open circle here, and when I look down, there's a closed circle. I want to go with the closed circle y value, which is -1. And then when x is 2, y is 1. We also want to practice evaluating using the equation itself. So we're going to verify the solution with the graph, but I'm going to show you how to evaluate just based on the domains here. So if you're looking, this blue equation is drawn on the graph for all values between -4 and -2. So it's x greater than -4 and less than or equal to -2. For this equation that I'm highlighting in yellow, we're looking at x values that are bigger than -2 and less than or equal to 1. So that's this middle piece here. Okay, the first piece is the blue piece. And then the last part is this portion here. If I want to evaluate an x value of -3, I want to look at all of these domains and see where -3 would fall in that range of x values. So here, x should be in between 2 and 6. I have -3 here. -3 can't go into this equation. -3 would fall here. It is bigger than -4 and less than or equal to -2, which means that anywhere I see an x in the equation in blue, I'm going to replace with a -3. So I get -9 plus 6, which is -3. If I check on my graph, when x was -3, y was also -3, so that answer is correct. Next I have when x is negative 2. When I look at my potential options here, a value of negative 2 I see in the yellow equation and the blue. When we see this number listed twice, you want to substitute negative 2 into the equation that has the symbol that is including that value. Remember, if it's underlined, it's including that value. It's less than or equal to, greater than or equal to. So because the negative 2 is included in the blue function, I'm going to put negative 2 in for x into the blue. So I get negative 6 plus 6, which is 0. So negative 2, 0 is in fact the correct answer. I can see it's the closed circle. Next one, when x is 1. I see 1 listed here. Okay. It is included here. I see the symbol is underlined. X is less than or equal to 1. So I can put 1 into the yellow equation anywhere I see an x. So 1 plus 3 is 4. The last one, when x is 4. X being 4 will fall into this range. 4 is bigger than 2 and less than or equal to 6. So I'm going to do negative 1/2 times 4 minus 2, which is negative 4. And I can see on the graph, if I find an x value of 4, the y value is in fact negative 4. Keep in mind that the hardest part about this is determining where these x values fall. To do that, you are looking at all of these compound inequalities to determine where is this number included, and then substitute into the corresponding equation. So if the value falls in this domain, then we'll sub it into the blue equation, so on and so forth.